Next we are going to see method to find the normal area, right? Probability of A less than or equal to x less than or equal to b. We know the area bounded by the curve p of x or f of x with x-axis, and the ordinate x is equal to a and x is equal to b is given by integral a to b p of x dx. Also, the probability density function p of x of the normal distribution is represented by probability of a less than or equal to x less than or equal to b is equal to integral a to b p of x dx, right? So this is x-axis, y-axis, this is the normal curve. X is equal to mu is z is equal to 0, the point of symmetry, right? This is x is equal to a left hand side, and right hand side limit x is equal to b, right? This is the area, required area, right? Probability of a less than x less than b. To find the area under the normal probability curve p of x or f of x with the x-axis and the ordinate x is equal to a and x is equal to b, probability of a less than or equal to x less than or equal to b, which is equal to integral a to b p of x dx. When x is equal to a, z is equal to a minus mu by sigma, right? Because we know z is equal to x minus mu by sigma, right? Let it be z1. And when x is equal to b, z is equal to b minus mu by sigma, that is let it be z2. So probability of a less than or equal to x less than or equal to b is nothing but probability of z1 less than or equal to z less than or equal to z2. That is the positive side. z1 is in the negative side, right? So integral z1 to z2 pi of z dz. That is 1 by root 2 pi integral z1 to z2. We know pi of z, right? E power minus 1 by 2 z square dz. 1 by root 2 pi e power minus 1 by 2 z square, that is pi of z. The value of this definite integral, which gives the area under the standard normal probability curve, that is nothing but area, right? So bounded by the line ordinates z is equal to z1 and z is equal to z2, has been evaluated and tabulated for different values of z1 z2 at the interval 0.01, intervals 0.01 or 0.05. So we have the table standard value of this, all this, right? Already we are having, are given in the normal probability table. That table is called normal probability table. The total probability value is always 1. So integral minus infinite to plus infinite p of x dx is equal to integral minus infinite to plus infinite in terms of z pi of z dz equal to 1. Hence the total area under normal probability curve is 1. So method to find the normal area, probability of x less than mu and x greater than mu probability, right? So probability of x greater than mu, which is equal to probability of x minus mu, subtracting mu on both sides. So x minus mu, mu minus mu 0, greater than 0. So divided by sigma. So probability of x minus mu by sigma greater than 0 by sigma 0, right? So that is nothing but probability of z greater than 0. Z greater than 0, total area 0.5. We know left side area 0.5, right side area 0.5. Similarly, probability of x less than mu can be written as probability of z less than 0, that is 0.5, right? Same idea. So this is x greater than, right? This is x less than. So total area both side, left side, right side, 0.5, 0.5, total area 0.5 plus 0.5, 1. Next method to find the right area of the right tile, right? To find probability of x greater than a. So case 1, a is greater than mu. A is the right of the mean x is equal to mu, that is the ordinate z is equal to 0 line, right? So since a greater than mu, corresponding value of z at x is equal to a will be positive, because a greater than mu, z is x minus mu by sigma, that is a minus mu by sigma. A is greater than mu, therefore it will be a positive term. When x is equal to a, z is equal to a minus mu by sigma, that is equal to z1 say. So x greater than 0, so probability of z greater than z1, total area, right area minus area between z is equal to 0 to z is equal to 1, that is equal to right area we know 0.5. So minus probability of 0 less than z less than z1, right? So this is the picture, this one, right? And the probability of z 0 less than z less than z1 value can be get from the normal probability table, right? Case 2, a less than mu, then clearly it will be negative, right? At x is equal to a, z will be negative, right? Because a minus mu by sigma, right? Mu is greater than means negative value. Let it be z1 minus z1, right? So probability of x greater than 0, right? Probability of z greater than minus z1. So area between z is equal to minus z1 and z is equal to 0, right side area, right? So probability of minus z1 less than z less than 0 plus 0.5. So this will be like this, right? So area between z minus z1 to the center point 0, then the right side area, total area. That is 0.5 plus probability of 0 less than z less than z1. So probability value, probability of 0 less than z less than z1 from table we can easily find out. Method to find the normal area, the left of the ordinate axis, first right of the ordinate axis. That is to find probability of x less than a. Case 1, a greater than mu. So same discussion. So a will be x at z value at x is equal to a will be positive, right? Let it be z1, right? So x is equal to mu. The diagram will be like this. So this is the total left area plus area between 0 to z1 clearly, right, from the diagram itself, right? So 0.5 plus area between probability of 0 less than z1, right? Similarly case 2, so a less than mu, then z value is negative, right, minus z1. So probability of x less than a, so probability of z less than minus z1, that is nothing but probability of z greater than z1. So because of the symmetry, right? So the diagram will be like this value, right? This is nothing but this value, right? Both are same, symmetric. About the z is equal to 0, the curve is, so this area is equal to that area, right? So 0.5, this is nothing but minus probability of 0 less than z less than z1. In terms of probabilities, the area and the standard normal curve are given by probability of z greater than or equal to z1, which is equal to probability of z greater than z1. The area right side area of the vertical line z is equal to z1. So probability of z less than or equal to z1 equal to probability of z less than s1 area left of the line z is equal to z1. So probability of z1 less than or equal to z less than or equal to z2 is nothing but probability of z1, both are same only, right? Z less than z2, area between the lines z is equal to z1 and z is equal to z2. Probability of a less than or equal to x less than or equal to b, which is equal to probability of z1 less than or equal to z less than or equal to z2, where z is equal to x minus mu by sigma, standard normal variate, right? z1 is nothing but a minus mu by sigma, z2 is b minus mu by sigma. Probability of minus infinite less than or equal to x less than or equal to mu, which is equal to minus infinite probability of minus infinite less than or equal to z less than or equal to 0, that is equal to 0.5, right? That is left side area. Similarly right side area, probability of mu less than or equal to x less than or equal to infinite, which is equal to 0 less than z less than infinite, probability value is 0.5. Now probability of e minus a less than or equal to x less than or equal to mu, which is equal to probability of minus z1 less than or equal to z less than or equal to 0. That is symmetric idea we are using, right? Probability of 0 less than or equal to z less than or equal to z1. Probability of minus infinite less than or equal to x less than or equal to a, which is equal to probability of minus infinite less than or equal to z less than or equal to z1, which is nothing but 0.5 minus probability of area between 0 to z1. Similarly, probability of a less than or equal to x less than or equal to infinite, which is equal to probability of z1 less than or equal to z, same arguments, right? Less than or equal to infinite, that is equal to 0.5 minus area between 0 and z1. So probability of minus a less than or equal to x less than or equal to a, which is equal to probability of minus z1 less than or equal to z less than or equal to z1. So we are using symmetric idea, right? So first area between minus z1 to 0, right? It will be splitted into 2. We can add first area minus z1 to 0 and 0 to z1. So you will get the total area minus z1 to z1. So using the symmetry condition 2 times, right? Probability of 0 less than or equal to z less than or equal to z1. In particular, we have probability of mu minus sigma less than x less than mu plus sigma equal to probability of minus 1 less than z less than 1. 2 times 2 times probability of 0 less than z less than 1 by symmetry. So 2 into 0.3413 from the normal table, 0.6826. Similarly, probability of mu minus 1.96 sigma less than x less than mu plus 1.9 sigma, that is equal to probability of minus 1.96 less than z less than 1.96. 2 times probability of 0 less than z less than 1.96. So 2 into from the table 0.4750, which is equal to 0.95. Next, probability of mu minus 2 sigma less than x less than mu plus 2 sigma is nothing but probability of minus 2 less than z less than 2. 2 times probability of 0 less than z less than 2. Here always we are using the symmetry condition. First split the area minus 2 to 0, 0 to 2. Then minus 2 to 0 again can be written as 0 to 2. Right? That is why we are getting 2 times. So 2 into 0.4772, which is equal to 0.9544. Next one, probability of mu minus 2.58 sigma less than x less than mu plus 2.58 sigma, which is equal to probability of minus 2.58 less than z less than 2.58. So that is 2 times probability of 0 less than z less than 2.58, 2 into 0.495, 0.99. So probability of minus 3 sigma less than x less than mu plus 3 sigma, which is equal to probability of minus 3 less than z less than 3. 2 times probability of 0 less than z less than 3, 2 into 0.49865, 0.9973. Right? Thanks.